Hello everybody and welcome to the second annual National Building Code webinar hosted by RAIC Emerging Practitioners and Jensen Hughes Consulting Canada Limited. As Canada's first advocacy group targeting interns and other emerging practitioners in the architectural profession, we are pleased to present this webinar to those of you in the architectural field and those of you expanding your knowledge of the building code. Today, I would like to first start off by thanking Afzana, the RAIC Emerging Practitioners Director, for organizing this awesome webinar for a second year in a row and letting me, Samantha Prue, be your host and trainer for a guide to understanding and applying the 2015 National Building Code, particularly with interest in Part 3, Fire and Life Safety. Now, I'm an accessibility and building code consultant. For the greater portion of my career, I have specialized as an accessibility consultant in barrier-free design and universal built environment aspects, but I have also done my fair share of building code consulting for thousands of projects, which is what allows me to educate you today on Part 3, Fire and Life Safety. I started out with the firm about 6.5 years ago. It's just a small firm called Lardon Muniac, about 20 people in Toronto and 2 people in Calgary. We were then bought out by a company called Serica Fire Consulting, who brought in more fire forensic work. And then about 1.5 years ago, we were bought out by a global entity, Jensen Hughes, of which now we cater to all aspects of life safety and offer many services beyond just the building code and forensic services. So without further ado, let's continue. These slides are only meant to be cue points which are expanded upon verbally by the presenter, myself, and are not meant to be comprehensive statements. So please, if you could, when you are reading or using this material and studying, I just ask that you also reference the National Building Code or the project-specific code that you are working with. Now, today's discussion is going to be telling you the building code fundamentals of Volume 1 and Volume 2, applying Part 3, Fire, Life Safety, and Accessibility, as well as teaching you about how the NBC is applied to existing buildings, renovations, alterations, etc. Now, a little brief history of the building code. What is the purpose of a building code and why do we have it? Well, it allows us to build safe buildings, take into consideration the health of occupants within the buildings, as well as assist in the design of fire and structural safety and protection, as well as ensuring that the built environment is suitable for those with disabilities. Now, a model code was desired to unify construction practices across Canada. Development of a national building code was first contemplated in Canada in the 1920s and abandoned due to the limited resources to complete the work. Originally, what Canada was doing, we were just using a number of codes that were derived from the United States. However, an administrative committee formed in 1932, which was called the National Research Council of Canada, to actually develop the National Building Code. The development of the Canadian Model Code reinitiated in 1937. And in 1941, the first National Building Code was released. To date, we are on the 14th edition, which is now the 2015 National Building Code. So, building code content. This seminar is going to mainly focus on Volume 1 of the 2015 National Building Code. I will be using the binder compendium, but there is also a book compendium. Throughout this, I will be referencing page numbers from the binder, which are also identical to that of the book version. So you will equally be able to follow along just as easily. So volume 1 is split into 3 divisions: Division A, Division B, and Division C. Division A has 3 parts: Part 1, Part 2, and Part 3. One discussing compliance and general requirements, objectives, and functional statements. Those are your first 3 tabs or first 3 sections in your code. Then in Division B, that's where you find all of your acceptable solutions. So all the literal application of code requirements. And that is separated into a number of parts, consisting of general, Part 2 is reserved, Part 3, which is our main focus of this seminar today, fire protection, occupant safety, and accessibility. And then we have structural design, environmental design, heating, ventilating, plumbing services, safety measures as part of the other part. Then it goes into Appendix C, which is your climatic and seismic data. Appendix D, which is your fire performance ratings. And then lastly, we have Division C, which is separated into 2 parts, which is typically general and administrative provisions, also known as the area where you get all of your permit application information. Then we have Volume 2 of the National Building Code, right here, just as large of a binder. And in this binder is everything that has to do with Part 9, housing and small buildings. Your attribution tables, fire and sound resistant tables, span tables, notes, and the index. So we will not be using Volume 2 at all in this seminar. That's all you'll be seeing of it, but it only consists of Part 9, which you will need for your seminar on Saturday. Reading the code and how to read it. So the code is broken into parts, sections, subsections, articles, sentences, clause, and subclauses. So when you see an individual digit, you know it's a part. When there's 2 digits, you're referencing a section. 3 digits is a subsection. 4 digits is an article. And then once you get into your bracketed numbers and letters, you are now specifying a sentence, clause, or subclause within that article. Volume 1, Division A, Part 1, General. So again, this binder, Volume 1, is separated into 3 divisions. Now, the application of Division A and its parts 1, 2, and 3 are applicable to all buildings. That's because all literal requirements come with an objective and functional statement. As for the application of Division B, Parts 1, 7, and 8 apply to all buildings, such as plumbing and your ventilation, as well as your general requirements. And then Parts 3, 4, 5, and 6 apply to most buildings, your large buildings, which also require structural, etc. And then you have Part 9, which is in your Volume 2, which is applicable to all buildings less than 600 square meters and less than 3 stories in building height, used for Group C, D, E, F2, and F3 major occupancies. Now, if you have a building that is less than 600 square meters, less than 3 stories in building height, but contains a Group A assembly occupancy, then you're pushed back to use Part 3, Fire and Life Safety requirements. It is no longer Part 9 building because Part 9 buildings aren't permitted to include an assembly occupancy. They can only include these select occupancies, which are residential, office, mercantile, and industrial occupancies that are low or medium hazard. Okay? Volume 1 deficiency, like I said, holds all of the information that's at the back of your book or back of the binder, very last few pages. And again, it talks about all your permit applications with regards to structural specifications, reviewing of work, and alternative solutions. With that said, I'm going to begin by explaining alternative solutions, otherwise known as variances. And that all commences under Division C. So the great thing about the building code is that you have an option. You either comply with the literal application of the code, or you use an alternative solution or variant that achieves at least the minimum level of performance required by Division B in the areas defined by the objectives and functional statements. In other words, you're trying to meet the intent of the literal application of the code. So what is an alternative solution? Any solution that is not an acceptable solution, so not a literal requirement, included in Division B of the code. When can an alternative solution be used? Whenever you want. Whenever you don't comply with the literal application of the code, but you think you can achieve the intent of the code, however, it's going to cost some money. Usually with the submission of an alternative solution, you're looking at a fee for that alternative solution package. You'd also be looking at a fee for the person doing the alternative solution if it's not going to be the architect or designer, i.e. the engineer who would be doing the analysis for the alternative solution. An alternative solution is a submitted document that demonstrates that the proposed alternative solution complies with the intent of the objectives and functional statements of the code. This document substitutes for the acceptable solutions which meets the requirements of Part 3 to Part 9 of Division B. So again, if you don't meet the literal application of the code, you have an opportunity to still comply under the building code, but instead you're arguing against the intent or the objectives and functional statements of that requirement. So proposed alternative solutions and related designs must meet the specific intents of the acceptable solution. Alternative solutions must be documented and verified. The evaluation and demonstration of the acceptability of the solution relies on risk analysis methodology. An alternative solution can be completed by doing a code analysis, providing test results, doing risk analysis, any other engineering analysis, mathematical and computer modeling, i.e. if travel distance doesn't comply, we can do time-based exit analysis, previous approvals from the authorities having jurisdiction. Mind you, that just because you had an alternative solution approved previously does not mean you can do the same thing for your next project and state, oh, but you accepted it last time, because each and every building is different. Typically, every scenario is different, whether or not you're arguing the same requirement for that building, and the authorities having jurisdiction are still going to want the same document and criteria and applicable fee for submitting that alternative solution package. You can also reference the acceptance under other published codes and standards. For instance, if you're working on a project in Alberta or in Ontario and they don't have the requirement that you're trying to argue against or want to comply with, and the National Building Code had that requirement, you could use that as part of your supporting criteria in your analysis, provided it meets the intent of the objective and functional statement outlined in your project-specific code. So how to begin an alternative solution? So what do? First, you're going to need access to your attribution tables, which are found in Division B of Volume 1. You're going to then locate the designated objectives and functional statements, which are found in Division A, Parts 2 and 3. You're then going to create a rationale or a risk analysis demonstrating that the alternative solution will meet the intent of the code. So let's do a scenario together. The scenario is that due to the design of a P1 level of the condominium, a travel distance of 45 meters cannot be achieved through an exit. Now that requirement derives from NBC sentence 3425 sentence 1, and we need an alternative solution because the design cannot meet the literal application of the code, and or the client or architect does not want to redesign and wants to maintain its extended travel distance. So our solution would be to do a time-based exit analysis, which is computer modeling, to prove that the conditions within the building are still safe and allow people to exit the building in a timely manner, which would be intended to meet the objective-based code. So let's do this together, okay? We're going to find an objective and find a functional statement related to sentence 34251 as it relates to a travel distance of 45 meters. So what we're going to do is we're going to flip to Division B, Part 3, which if you're using the binder is 1, 2, 3, 4, 5, 6 tabs down in your code. Then we're going to flip almost all the way to the back until we see section 310. Which is on page 3-174, where you will see attribution tables for part 3. We're going to then flip those pages until we find sentence 3425. And that's going to be located on page 3-198, second column, 6th requirement from the top, 3425 location of exits. And you'll notice that for 3425 sentence 1, we get a functional statement of F10 and an objective statement of OS 3.7. So in order to go find that functional and objective statement, where are we going to go? We're going to go to Division A, Parts 2 and 3. Now, a funny thing that was mentioned was that in the attribution tables, you list the functional first and the objective statement, but yet in Division A, the objectives are in Part 2 and the functional statements are in Part 3. So we're actually going to look up the objective statement first. So again, we are now back at the front of the book or binder in Division A, Part 2. And now if you flip the page from 2-1 to 2-2, you'll notice that our objective statement is the very last one on the page, 2, which is OS 3.7, right there. So an objective of this code is to limit the probability that, as a result of the design or construction of the building, a person in or adjacent to the building will be exposed to an unacceptable risk of injury due to hazards. The risks of injury due to hazards addressed in this code are those caused by OS 3.7, persons being delayed in or impeded from moving to a safe place in the event of an emergency. Okay, so now we have our objective. We're going to flip to part 3, just a couple pages over to find our functional statement. This we can find on 3-2. Right at the top of the page, you will see a list of functional statements, one of those being F10, which reads, to facilitate the timely movement of persons to a safe place in an emergency. Therefore, the intent of requirement 34251 regarding travel distance is to ensure that people can make it to an exit facility in the event of an emergency in a timely manner without being delayed or impeded. So as a result, you're going to summarize that result and your testing and analysis criteria and data, and you're going to summarize that into a document and issue a statement stating that although you don't meet the literal application of the code, you do comply with the intent of the objective-based code. Therefore, this is deemed acceptable. The results and documentation will be submitted to the AHJ and will await the acceptance or non-acceptance. Again, ultimately, you can do the same alternative solution over and over again. Sometimes it'll be accepted, sometimes it'll be rejected. It is all up to the AHJ, so your authority having jurisdiction. It usually results in that person feeling that they're liable for that document or the repercussions of that document, even though an engineer or architect would be signing off or stamping off on that document. Now, just to further explain this and make sure that I am being clear, the NBC is an objective-based code, not a performance-based code. It tells you what you need, not how well your building performs. So for example, as we were saying, travel distance in a typical sprinklered floor area cannot be less than 45 meters. This is a prescriptive requirement of the objective-based code, whereas a performance-based requirement might say, in a typical sprinklered floor area, occupants must be able to exit in 2 minutes and 36 seconds. Again, that's hypothetically and performance-based. We apply an alternative solution when meeting the prescriptive requirements of the objective-based code cannot be reasonably done. An example with this would be our floor area has a travel distance of 51 meters, which is in excess of 45 meters as required by 3425 sentence 1. Thus, we will then have to investigate the engineering analysis or the performance of the non-compliant design relative to a design that complies with the 45-meter travel distance. During our engineering analysis, we may find that occupants in the non-compliant building may have more time before tenability limits are reached when compared to that of a code requirement. Perhaps our design has a higher ceiling to hold more smoke, or that we've considered additional safety measures such as smoke extraction or a passive air system, which will extract smoke out of the floor area and allow people to get to an exit safely. As such, this would make a strong case for acceptance of the alternative solution. However, just because an alternative solution shows better performance than the code-compliant design, it is all still up to the authority having jurisdiction as to whether or not they will approve it. Okay, so now that I've let you know about Division C and the permit application and alternative solution process, we are going to dive right into Volume 1, Division B, Part 3, Fire Protection, Occupant Safety, and Accessibility, otherwise known as Fire and Life Safety. So we're going to discuss vertical compartmentalization, the floor assemblies and shafts, and how we create vertical compartments along a building, such as floor assemblies, elevator shafts, service shafts, stair shafts, etc. We're going to look at spatial separation and exposure protection, so how to protect one building from another when a fire breaks out in one. Horizontal compartmentalization, so once we've vertically compartmentalized, how do we get within a floor area and compartmentalize it within the floor? And that could take into consideration single or multiple tenants, public corridors and corridors used by the public. I will also be letting you know the difference between those two terms later on. We're going to look at special protection. What's the difference between hazardous areas, sensitive areas, when we're protecting people from the outside versus the inside? We're going to look at egress and exiting and what the difference between those two terms are. We're going to be looking at interconnected floor spaces and mezzanines, as well as fire access routes and protection systems, high buildings and the additional safety measures applicable to high buildings. We're going to learn how to calculate occupant load and exit capacity and plumbing fixtures. And then we're going to look at barrier-free design, which also includes the protection of floor areas and a barrier-free path of travel, otherwise known as areas of refuge. But first, we're going to look at a few definitions and concepts that are important as we move along. So what is the difference between a major occupancy and a subsidiary occupancy? So a major occupancy is the principal occupancy for which a building or part thereof is used. It can include smaller subsidiary occupancies. So right now in this image, we have a 5-story Group C residential occupancy situated above one level of an F3 storage garage, otherwise known as a parkade. The storage garage is classified as a subsidiary occupancy to that of the overall Group C residential occupancy. Now, if this parkade in the basement were to be open to the public and not just serving the residents above, it would become its own major occupancy as it's self-sufficient and doesn't rely on the major occupancy above. Multiple major occupancies. So that is where you can have multiple major occupancies within one floor area. You could have a Group E, a Group A2, and a Group B, but it all comes down to how we separate and compartmentalize those major occupancies within that floor level. Multiple major occupancies can also be superimposed above one another. A few definitions that are quite important. You need to know building height, which is the number of stories between the floor of the first story and the roof. What is the first story? That doesn't always mean it's the ground level. The definition of first story is the uppermost story having its floor level not more than 2 meters above grade. What is grade? Grade is the lowest of the average levels of finished ground adjoining each exterior wall of the building. For instance, if you have a building where the main level is half below grade and half above grade, you would then likely have to do a grade analysis to determine whether or not the basement or the main level is in fact the first story. This is a huge deal when it comes to whether or not your building is a high building or not. Building area is the greatest horizontal area of the building above grade. In this case, you can't always just take your site plan and measure the area around the building. You need to take into consideration all the floor levels, and whichever one has the largest area around the exterior walls is going to be your building area. As per the example below, you can see that the second story would be the one to designate as the overall building area. This image, again, is the first image, just simplified, in that the second floor area would be the determining factor for building area. Now, I probably should have put this slide a little earlier, in that it does define the building classifications if you are unfamiliar with such terms. Now, building classifications are how you categorize the different types of buildings and their uses. Any type of A occupancy is an assembly occupancy, and it serves the public. So whether that contains an arena, a performing arts, theater, restaurants, or otherwise where occupancies can gather in an open air stadium, if you will. Anything with a B is a detention occupancy, care and treatment occupancy, or a care occupancy. So B1, detention occupancy, is your jail establishment. Then you have B2, care and treatment, which would otherwise mean it's a hospital, somewhere that provides treatment to its patients or residents. And a B3 is a care occupancy. So that means they might provide assistive living services, but they wouldn't provide treatment in-house. They would likely, in the event of an emergency, call an ambulance, and that ambulance would bring them then to a hospital where treatment could be provided. The Group C occupancy is a residential occupancy, so that could be your college dorms to your apartment buildings to your condominiums, or a single residential home. Group B is your business and personal services occupancies, so office spaces essentially. Group E, mercantile occupancies, commercial, retail. And then you have your F1, F2, and F3, which are your high, medium, low hazard industrial occupancies. Now, in order to determine what level of industrial occupancy you are is based on the flammable content within that building. The levels of flammable content are defined in the definitions of high hazard, medium hazard, low hazard industrial occupancies in your defined terms. Where can your defined terms be found? Great question. Division A, Part 1. Defined terms begin on page 1-3, right at the beginning of your book or binder. Again, under Division A, Part 1. So we're going to get right into compartmentalization. Very similar to how these honeybees protect their nectar in the honeycomb, is much like how humans protect their humans by compartmentalizing them in buildings. Again, some more definitions which are important knowing for compartmentalization. What is a fire compartment? An enclosed space in a building that is separated from all other parts of the building by a fire separation. A fire separation is the construction assembly that acts as a barrier against the spread of smoke and fire. Fire resistance rating, the time in minutes or hours that a material or assembly of materials will withstand the passage of heat and flame. So just because something has a fire resistance rating doesn't mean that it has to be constructed as a fire separation. Now, typically, the code and its intent is to provide, for example, floor assemblies with fire separations that have a fire resistance rating. In a smaller building, you'll have a lower fire resistance rating, and in a larger building, you're going to have a higher fire resistance rating. Reasons being that the time allotted to a fire resistance rating is based on how much time a firefighter or emergency personnel has within the building to get in and out before the floor assembly starts to disintegrate in a fire emergency, or starts to collapse or break down. Simple illustration, typically floor assemblies have a fire separation, walls, fire separations when separating two compartments, whereas your supporting structure will just have a fire resistant rating. Sometimes, depending on your 322 article, you might have a waived fire resistance rating if your supporting structure is of non-combustible construction. So now we're going to vertically compartmentalize. So our floor assemblies, exit stair shafts, vertical shafts, elevators. There's 4 factors that affect the degree to which a building is vertically compartmentalized. The 3 major factors. So you need your major occupancy, you need to know your building area, and you need to know building height. With regards to firefighting and suppression, that's an added benefit. Sometimes the client already knows if they want to sprinkler the building, helps with insurance. Or if they don't know whether or not they want it, and you can use the three major criteria, major occupancy, building area, building height, find a 322 article, of which will tell you whether or not you need the building to be sprinklered. So a 322 article is found in subsection 322, division B, part 3, so 6th tab in your binder, or part 3 in your book. And those are going to tell you all your construction requirements. So it's going to summarize whether or not you need combustible or non-combustible construction. Again, it'll tell you whether or not you need to sprinkler the building, not sprinkler the building, floor fire ratings, mezzanine fire ratings if applicable, roof fire ratings if applicable, and it'll also tell you the fire resistance rating applicable to your structural components, supporting those elements. Now, once you have your 322 article and you have a floor assembly fire separation rating, you can also use that to determine your exit stair shaft fire separation requirements, elevator shaft requirements, and your service shaft fire separation requirements. So a lot of things stem from knowing how to properly use your 322 articles. So now we're going to go through some 322 articles so that you can become comfortable with applying a 322 article to a building description. Okay? So we are going to open our codes and flip to our 322 articles. Now you should be in Division B, Part 3 of your NBC, Volume 1. And the 322, or subsection 322, fully begins on page 3-39. Your actual 322 articles with regards to construction requirements begins on page 3-43 at 32220. Group A, Division 1, any height, any area, sprinklered. And those 322 articles lead you all the way to 32290 on page 3-68. So from page 43 to page 68, those are all your construction requirements for all types of major occupancies, ranging from assembly all the way to your industrial hazard occupancies. Okay? We're going to do 2 examples for a single major occupancy, and then we're going to do 1 large example of a multiple major occupancy, and then I've added one that you can do on your own. So we have a single major occupancy, and the criteria is as follows. We have a group C. The building area is 2,000 square meters, 5 stories in building height, and it is sprinklered. The 322 article you're going to apply is 32248. Group C, up to 6 stories sprinklered. And as you read through, you'll notice that the building has to be of non-combustible construction. The floor assembly and supporting structure are permitted to have a 1-hour fire resistance rating. So what you would do is you would apply that 1-hour fire resistance rating to each of your floor assemblies, and that fire resistance rating would then help you identify your requirements for your exit stair shafts, elevator shafts, and so on. But we'll apply those requirements to the multiple major occupancy example. Right now, we're just learning how to apply floor assembly ratings and determine the construction required. Okay, so example 2. Our criteria is as follows. Group E, the building area is 1,500 square meters, building height 3 stories. It is sprinklered and faces one street. So if we flip through, we're going to try and find our Group E requirements. And now we're just going to try and determine where that criteria falls in. You always want to go least restrictive to more restrictive. In this case, the least restrictive 322 article is going to be 32267, Group E up to 3 stories sprinklered. Faces one street was just there to throw you off. Typically, you don't need that unless that information unless your building's not sprinklered. Anyways, the construction is going to be can be of combustible construction or non-combustible construction. The floor assemblies, no matter what, must be of fire separations with a 45-minute fire resistance rating, whether combustible or non-combustible. However, your supporting structure may have a fire resistance rating of 45 minutes or be of non-combustible construction. As you can see, we have a group E, and we would apply our floor assembly ratings to the floors above. It's as easy as that. Now we're going to do a multiple major occupancy example. In this case, if you look at articles 3225 to 3228, and that's at the beginning of your 322 articles, it'll give you information on buildings with multiple major occupancies, superimposed major occupancies, exceptions for major occupancies, in which case, in a building containing more than one major occupancy, the requirements for this subsection for the most restricted major occupancy contained shall apply to the whole building. However, when you have superimposed major occupancies, where one major occupancy is located entirely above another major occupancy, the requirements in this subsection for each portion of the building containing a major occupancy shall apply to that portion as if the entire building were of that major occupancy. So in this case, this is again just an exemplar for indicating superimposed major occupancies, in which case we could have a group E, a D, a C, a B, an A, it doesn't matter. However, a lot of the time you want to put the more restrictive 322 article items lower and then work your way up. So that way you don't have all the restrictive requirements on the upper floor that then have to apply all the way down. Okay? So you want the most restrictive requirements on the ground floor, and then as 322 articles lessen with regards to restrictions, you can build up. I'll continue to explain this as we gradually move through the example. So here's the example. We've got a building, 5 stories, that consists of a group E on the ground floor, a group B on floors 2 and 3, and a group C on floors 4 and 5. The building is 2,000 square meters, the building height is 5 stories, and the building is sprinklered. Okay? So we're going to start with the E occupancy on the ground floor. As per 3226 and 3227, where you have multiple major occupancies, you want to treat the entire building as if that's the only occupancy in it. In which case, you want to treat the building as if it's a 5-story group E major occupancy. That's 2,000 square meters. And this will give us Article 32264, Group E, any height, any area sprinklered. The building must be non-combustible construction and have floor assembly and supporting structure with fire separations having a 2-hour fire resistance rating. We want to apply that floor assembly rating to the floor above the major occupancy, in which case, again, we pretended that the entire building was a group E, and we're going to apply that 2-hour fire resistance rating to the floor above the group E, otherwise the ceiling above your group E, because we're creating one compartment separated from all other compartments above, okay? Secondly, we're going to move on to floors 2 and 3, which consist of a group E occupancy. So now we're going to treat the entire building as if it was a group E occupancy. So 5 stories, 2,000 square meters, only containing a group E. You're going to flip to your 322 articles. You're going to find your 322 item, in which case we come up with 32257, Group B, up to 6 stories and sprinklered. So that means your building is going to maintain non-combustible construction. Your floor assembly and supporting structure will have 1 hour fire resistance ratings. Okay, like we did before, we're going to apply that floor assembly rating to the floor above the Group B major occupancy, right? So we're creating, again, more compartments separated from the remainder of the building. And it's always the floor above. Now, we're going to do the last 2 stories, which is Group C, stories 4 and 5. We're going to treat the entire building as a 5-story residential building. Try to find the 322 article. In this case, we come up with 32248, non-combustible construction, floor assemblies required to be of fire separation with 1 hour fire resistance ratings. Again, we want to apply that floor assembly rating to the floors above the Group C. Now you'll notice that the floor above the 4th floor is 1 hour, but we've applied a 0 hour fire resistance rating to the roof. Why? Well, under 32217 and 32512, sentence 6, sprinklers are permitted to be used in lieu of a roof rating for assembly occupancies consisting of a marina, pool, or gymnasium. However, in the explanatory material of 32512, sentence 6, through permission of the authority having jurisdiction, this could also be used on alternate building occupancies. In real life applications, it is almost always accepted to waive the fire resistance rating of a roof if you have a sprinkler system, provided the rooftop is in an occupied space, it's not being used as an amenity, terrace, etc. Otherwise, per literal application of the code, the roof would require a 1 hour fire resistance rating. Okay, so now when you put the whole thing together, we'll have the floor assembly above floor 1 having a 2 hour, and then all other floor assemblies will be 1 hour. Because the building is sprinklered, we assume the roof isn't being occupied or being used as a rooftop amenity space, but we can waive the fire resistance rating. That's it. Now, once we've vertically compartmentalized, we can look at the exit shafts, the elevator shafts, and the service shafts, of which are all based on your floor assembly rating. So in this case, say the entire building was classified as a Group E major occupancy. That means each floor assembly would have a 2 hour fire resistance rating. If we look up exits 3441, I won't do all of them, but I'll go through 2 of them with you. So under 3441, if I get there. Fire resistance rating of exit separations, page 3-134. It says, every exit shall be separated from the remainder of the building by fire separation having a fire resistance rating not less than that required by your subsection 322 article, but not less than 45 minutes. Because I'm required to have a 2 hour fire separation rating, I am also going to have a 2 hour rated exit stair enclosure. When I'm trying to determine elevators, they are going to be identical as well, but you determine that under 3531. If we want to look at service spaces, we would want to look at 3631, which can be found on page 3-151. And you'll see a table there called Table 3631, fire separations for vertical service spaces. Right there. And you'll notice fire resistance rating of fire separation required for the floor assembly. Right there, you see 2 hours right at the bottom. You follow your hand over, and the minimum fire resistance rating of that vertical surface space is required to be 1 hour. So you actually get a bit of a reduction there. Now, something that comes up as a question quite often is that based on your 322 article, if you notice that the lower floors are not required to be sprinklered and the upper floor is required to be sprinklered, this would result in each of the floors below the sprinklered floor level having to be sprinklered as well. Or say you had 1 hour, 1 hour, 1 hour, and then 2 hour floor fire separation, your exit stair shafts all the way down would also be 2 hours. Except that your floor assemblies could remain 1 hour, 1 hour. It's just that your 2 hour floor assembly must now be the same as your 2 hour exit stair shaft all the way down, because firefighters need to be able to come up, remain protected for that 2 hour period from the top level, which requires that more restricted fire resistance rating. Okay? So here's an example that you can do on your own. I've provided the building criteria. You need to find the 322 article, building, whether or not it's required to be sprinklered, and what are the applicable floor fire separation ratings, okay? It's a 3-story Group E office situated above 1 basement level below grade, otherwise known as a parkade, Group F3 occupancy. Now I'm going to go through the answers with you because there is an item that might throw you for a bit of a loop. Okay? So here's the 322 articles, all right? Now, is the building required to be sprinklered? No. What are the applicable floor fire separation ratings? 45 minutes. If you look at both of those 322 articles, 32260 and 32283, you'll notice that you require a 45-minute fire resistance rating for each of the floor levels, including the Group F3 occupancy. But why have I indicated a 1.5 hour rating? Well, because it's a parkade, you would also have to look at the horizontal compartmentalization requirements, which are found in section 3.3. With that said, a storage garage under Article 3356 is required to be separated from the remainder of the building by a fire separation with a fire resistance rating not less than 1.5 hours. That means the 1.5 hours is more restrictive than that found in your 322 article. Therefore, you can no longer use the 45-minute, and you must apply the more restrictive requirement, which is 1.5 hours. Okay? Perfect. Now we're going to get into spatial separation and exposure protection requirements. This we can all find in subsection 323. Three two three begins right after your 322 articles on page 3-69. If you want to follow along, again, top of the page says the exact same thing: spatial separation and exposure protection requirements. So what is the theory behind spatial protection and exposure protection requirements? Well, one of the fundamental principles upon which the code is based requires buildings to be designed to protect adjacent buildings from fire exposure. The protection provided must be from the exposing building. Exterior walls are required to be rated for exposure to fire from inside the building. So if a fire breaks out in one building, you need to make sure that it's not going to have an impact on adjacent properties. The history behind this is that in 1958, the town of Altville, Ontario was permanently flooded as part of the creation of the St. Lawrence Seaway. After the town was abandoned, the vacant buildings were burned to study how a fire in one building affects the adjacent buildings. These fires are known as the St. Lawrence burns. What is an unprotected opening? That is a doorway or a window or an opening other than that equipped with a closure having a required fire protective rating, or any part of the wall that has a fire resistance rating less than required for the exposing building phase. In other words, if you have a doorway, window, or opening that's not protected, that is considered an unprotected opening. If you have a closure, such as a fire shutter over an opening, that's no longer in your area of unprotected openings as it's protected by a closure. The unprotected opening limit tables in subsection 323 are based on the results of the St. Lawrence burns. The maximum permitted unprotected openings can be determined on the basis of the following information. So you need the occupancy classification, you need the exposing building phase and the area of the fire compartment you're calculating, or you need to determine the limiting distance to a property line or the center line of a public thoroughfare, and the presence of sprinklers, because that is going to help you determine what table you need to use, whether it be table 3231B for non-sprinkler buildings, or 3231B or E for sprinkler buildings. Sprinkler buildings are more fun or more easy to calculate, shall I say. Anyways, exposing building phase. What is that? It's that part of the exterior wall of a building which faces one direction and is located between ground level and the ceiling of its top story, or exterior walls of an individual compartment. So you have the option to either, can I draw with this? To either calculate exposing building phase using, sorry, this isn't working. 1 second. You can either use, I'll try again, the area of the entire exposing building phase, okay? A beautiful square I just drew. Or where building is divided into fire compartments with a minimum fire separation having a fire resistance rating not less than 45 minutes, then you can actually calculate the required percentage of unprotected openings per compartment. And that can actually help you have more unprotected openings in your overall exposing building phase. Now, the distance from an exposing building face to a property line can also be measured to the center line of a street, land, or public thoroughfare, or an imaginary line between two buildings or fire compartments on the same property measured at right angles to the exposing building face. So if I have building Y and building X separated by a property line, you would measure from the closest portion of the exposing building face to the property line. And you would do the same thing for building X, closest portion of the building to the property line. And it's as easy as that. Now, construction of exterior walls. Unprotected openings permitted or required construction of exterior building face can be determined based on separate limiting distance calculations. So, for instance, this yellow dotted line right here is what you would use to determine the fire resistance rating required of your exposing building face. So this is one compartment, okay? So you would take the limiting distance from the closest face of that compartment to the property line, and that's going to be your limiting distance to determine the fire resistance rating of this compartment. You would take this dimension, okay, it's going, sorry, this dimension. Depending on your municipality, some like you to measure from center line to center line, so center wall to center wall. Other municipalities prefer that you use from inside of compartment to inside of compartment. So it's always nice to ask who you're dealing with at the city as to what they prefer your calculations, so that way you don't have to go back and redo them. We'll take the size of the compartment times the height of the compartment. Again, sometimes it's center line of floor slab to center line of floor slab, or it's in top of floor slab to bottom of floor slab, depending on what the city requests. That will get you the area of your exposing building face. Then you'll take your limiting distance and you'll apply it to these tables, and voila, you'll know whether or not your exposing building face is required to have a fire resistance rating, and whether or not it has to be a non-combustible or combustible construction and cladding. Now, when it comes to determining your percentage of unprotected openings, you can actually measure from the face of the opening to your property line. For that limiting distance. And that will give you, so you'll take your area of exposing building face, your limiting distance to the opening to determine your percentage of unprotected opening. With that said, I also have a drawing somewhere that I'm hoping will help you guys out with another example. So like I said, this is one compartment in this image, but in this image here, okay, we have, let me try and see what I'm doing. So we have 3 separate compartments. We have Unit A, Unit B, and Unit C, okay? And our property line happens to be on an angle. Unit A, you always want to measure limiting distance from the closest part of the compartment to the closest portion of the property line. Not center of compartment to property line, it's always your closest dimension. And that will tell you what the fire resistance rating, if applicable, is required of this exposing building face for this compartment. Now, in order to use individual calculations for each compartment has to be separated by a fire separation with a fire resistance rating not less than 45 minutes. Now in Unit B, we'll have a limiting distance from our opening, the closest portion of that opening, to the closest portion of the property line to determine our percentage of unprotected opening. We can then, in order to determine the fire resistance rating for the construction, use the closest limiting distance from the exposing building face to the property line. You would do the same thing for Unit 3. No openings, but construction. So we would have to take the limiting distance from the closest edge of the compartment to the closest portion of the property line, measured at a right angle to the building face. We're going to do an example together. So we have some criteria here. We've got a group F2. The exposing building face of a compartment is 90 square meters. So that compartment identified in yellow would be separated from the remainder of the building on the interior by a 45-minute fire resistance rating. Then we have a limiting distance of 4.5 meters, and the building is sprinklered. So that is enough criteria to get you going on how to determine your exposing building face construction as well as your percentage of unprotected openings. Because the building's sprinklered, that immediately means you get to look at either table 3231B or table 3231E. On page 3-75. You'll notice in the first line of the table, it will tell you what occupancies each table applies to. So table 3231B applies to unprotected openings for group A, B, C, B, and F3 occupancies. As we stated, the criteria for the building we're working on, it's an F2, so we're not going to be using 3231B. We're going to be moving down to table 3231E, which applies to groups E, F1, and F2 buildings. Now we have a 90 square meter exposing building face, so we're in between the 80 and 100 mark. And then we have a limiting distance of 4.5 meters, which is in between the 4 and the 5. So we are going to have to do some interpolating. So we're going to input our interpolation criteria, and we're going to come up with a result of 23.5% maximum permitted openings. Anything greater than that would have to be protected, but 23.5% of those openings may remain unprotected. For instance, if you had 46.5% openings, you would have to protect half of those openings because you're only permitted 23.5%. Now, how do you determine your percentage of openings in your wall? You measure the area of each opening and you divide it by the area of your exposing building base. If you look at 3.2.3.10.2, it permits 100% unprotected openings where 9 meter limiting distance regardless of occupancy classification or if sprinkled or not. So if you also look at these tables, 3231D and 3231E, you'll notice that as your limiting distance grows larger, you're permitted almost 100% unprotected openings. And for group A, B, C, D, and F3 occupancies, any limiting distance beyond 9 meters is permitted 100% unprotected openings. Whereas when you're looking at group E, F1, and F2 occupancies, then you really get to anything past 15 meters is essentially permitted 100% or is permitted 100% unprotected openings. But in this 3.2.3.10 sentence 2 item, if you're on the ground floor level and you have a limiting distance of 9 meters, you're permitted 100% unprotected openings no matter what. Okay. It actually reads, one sec, the exposing building face of a story that faces a street and is at the same level as the street is permitted to have unlimited unprotected openings if the limiting distance is not less than 9 meters. So yes, that's correct. It's typically the ground floor level or the floor level that opens onto the street. That's permitted 100% unprotected openings. Now, how do we determine the construction and the exterior wall cladding? Because we're permitted a maximum unprotected openings of 23.5%, we are going to look at table 3237 as indicated on your screen here. And we are going to move to the second or the third row, I guess. It says group E, group F1 or F2. We are 23.5, which puts us in between 10 and 25. That would require us to have a 2-hour fire resistance rating, permitted to be of combustible or non-combustible construction. must have non-combustible cladding. And when it comes to combustible or non-combustible construction, it really comes down to your 322 article or whether or not your building is permitted to have combustible construction. Otherwise, you're likely going to have non-combustible construction as you're exposing building phase construction anyway. Okay. What about protection of exit facilities? When you have an exit, exiting outside, and you have an opening that is located within 3 meters of that exit opening, and that opening in the adjacent wall meets at an exterior angle of less than 135 degrees, the opening in the exterior wall has to be protected, right? Because if you're exiting out of a building and there is a fire in the adjacent compartment and there's an opening within 3 meters, that could put an impact on the individuals trying to escape the building safely. Therefore, that window within 3 meters is going to be protected. How do you protect an opening? You can either use glass block, wired glass, or a fire shutter. Now, the NBC does not have a literal requirement regarding a sprinkler protected glazed wall assembly. However, you could use it, but you may require an alternative solution or variance to be approved first by your authority having jurisdiction. If you're working on projects in Ontario, the Ontario Building Code actually has a Article 31818, which speaks to the requirements of a sprinkler protected glazed wall assembly, which is permitted. However, if you're working in other provinces or with the National Building Code, you would require a variance or alternative solution to use a sprinkler glazed wall assembly. Now we're going to move into horizontal compartmentalization. So we've done the vertical compartmentalization. We have constructed the exterior of our building appropriately with protected openings where necessary and fire resistance ratings where necessary. Now we're going to get into the floor area and compartmentalize any areas that may need protection. Okay? So this could mean separation of hazards or separation of sensitive areas. What's the difference? A special hazard area is a room and space that, due to an associated hazard, are required to be separated from the remainder of the building for the protection of occupants outside of these rooms, okay? Outside of these rooms. In which case, these rooms likely hold something hazardous within them, so that if there were an explosion within that room, we want to keep it concealed, compartmentalized within that room so that it doesn't escape and affect people outside of those rooms. Examples would be janitor's rooms, common laundry rooms, welding and cutting rooms, libraries, etc. Why libraries? They're full of paper, which is also combustible material and highly flammable content. So, sensitive areas are rooms and spaces that, due to an associated hazard, are required to be protected from the remainder of the building for the protection of occupants within these rooms. Now, this would take into consideration your hospitals, your care occupancies, assembly occupancies with high occupant loads, contained use areas, or dwelling units within a family, multifamily building. Why would you do this? Because if you have a hospital and there are people that are unconscious, non-ambulatory, or have just undergone an operation, they are not going to physically be able to exit the building in the event a fire alarm were to go off. So what you need to do is you need to create safe compartments within the floor area so that in the event of an emergency, should something happen in one portion of the building, they can be escorted or evacuated to the next portion of the building until conditions are considered safe. If unsafe, then they would implement other measures to get the people outside of the building or to another building as fast as possible for their safety, right? So again, you want to protect these people in the compartment. Separation of compartments. So a great table to use if you're ever trying to determine the fire separation between major occupancy is NBC table 3131. So for example, if you have a restaurant that's located next to their neighbor, which is a retail space, you can go to this table and you'll look at A2E and you'll realize that fire separation separating these two compartments must be not less than 2 hours. Let's do another example. So we have a floor area with multiple office spaces within it, okay? So you look at your table 3131, B, you need nothing. Essentially, you need nothing, no fire separation, okay? But this is also confirmed under, again, all your horizontal compartmentalization requirements are also going to be found in section 3.3. So in sentence 3.3.1.1, it confirms that group B occupancies that are placed side by side are not required to be separated from each other by a fire separation or having a fire resistance rating. You can just have plain drywall, partition walls, not smoke sealed, nothing. Public corridors. Okay, public corridors. A lot of the requirements you can find in 3.3.1.9. They are required to be 1100 millimeters wide, provide access to 2 exits in 2 separate directions, permitted to have 100 millimeter obstructions on either side, and dead-end corridors are not permitted to exceed 6 meters unless located entirely within a suite. Okay? Dead-end corridors do not apply within a room or an office space. Dead-end corridors apply to corridors used by the public or a public corridor. So something that provides you with access to an exit. What is a public corridor? A public corridor that provides access to an exit from more than one suite. Okay? So floor area. Once I have more than one suite, which means 2 or more suites within a floor area, those suites or rooms must open into a public corridor that leads to not less than 2 exits in 2 separate directions. Okay? Corridors used by the public serve one tenant. Okay? So we have one tenant, and that means we have a corridor used by the public. Why would one tenant have a corridor used by the public when they can just access and exit directly? Well, typically, a client or an owner wants this option because it provides security, so anyone coming up through the elevator lobby doesn't just wander right into their office space, or if they don't meet travel distance to an exit from within their space. And I'm going to get into how you apply that requirement and where that requirement is found in the next few slides. Okay? In the meantime, we're going to do an example about dead-end corridor, whether it's permitted or not. Your client would like to lease out the unit identified in yellow. Is she permitted to do so? The dead-end corridor is 7 meters long. If we go to 3.3.1.9, sentence 7, a dead-end corridor is permitted provided it is not more than 6 meters long. Right then and there, not permitted. However, if that dead end was less than 6 meters, it would be permitted. Now I included this slide for those of you that work on real-life projects. Depending on what province you're working in, sometimes you can get away with an extended dead end, provided you have a second and separate means of egress not opening into a dead-end corridor. However, again, that item is not addressed in the NBC, therefore, this would still remain non-compliant. Public corridors. Sorry. Section 3314. This is where you find all of your public corridor fire separations. So we're going to start with sentence 1, the generic requirement, which reads, a public corridor shall be separated from the remainder of the story by a fire separation having a 45-minute fire resistance rating. Okay? Oh, there we go. So a public corridor constructed has a 45-minute fire resistance rating. The blue, we're going to pretend this is a high-rise office building, in which case the exit stairs and your elevator shafts would have to be separated from the remainder of the floor area by a 2-hour fire resistance rating no matter what. And we learned that from our 322 articles in our vertical compartmentalization. But for your public corridors within your horizontal floor area, we would require a minimum 45-minute fire resistance rating. Hold on, we are getting to those exceptions in a second, okay? So where the entire floor is sprinklered, public corridors do not require a fire resistance rating. So that is mentioned in sentence 3. If a story is sprinklered throughout, no fire resistance rating is required for fire separation between a public corridor and the remainder of the story, provided the corridor does not serve a care, treatment, or detention occupancy or a residential occupancy, okay? Where's them? It's not showing up. Anyways, yeah, there we go. So if you sprinklered, your public corridor then goes down to a 0-hour rated fire separation. So that still means your wall has to be constructed slab to slab construction, non-combustible material, and smoke sealed. Okay? Then we get into our exceptions listed in sentence 4. This one's the fun one. So where the entire floor is sprinklered and travel distance from all points of the floor to an exit is less than 45 meters, the public corridor does not require a fire separation. Okay? So you comply with travel distance, your building is sprinklered, your public corridor can now just consist of a simple partition wall. No fire separation, no fire resistance rating. But again, your stairs and your elevator shafts would still maintain their fire resistance, their fire separation from the remainder of the building. There's also another exception allocated in 4C that just states if you do have base building washrooms or washrooms facing the public corridor, they don't need to be separated from the corridor, provided the remainder of the corridor is separated from the remainder of the floor. Okay, now we're going to move into egress and exiting. What's the difference? All right, so the easiest way to explain this is that an egress door provides access to an exit from a floor area. Okay, so we're not yet outside of the building, we're not yet in a safe haven or away from the fire. We're still within the building, but we're en route to an exit. And all of those egress requirements are going to be found in section 3.3. So all egress requirements begin with a 3.3. Okay, so in this case, that's an egress, means of egress. I'm still not outside, but it's pointing me in the direction of an exit. As for exits, they provide you with access directly outside to a public thoroughfare through a firewall, and a horizontal exit in a firewall, which puts you in another building, somewhere safe away from the fire emergency. In this case, it's a door labeled deliberately with an exit sign above it, saying on the other side of this, I am away from danger. And all of those requirements are going to be found in 3.4. All exit requirements begin with a 3.4. Okay, so exit. Again, if we were looking at section 3.4, we would read that where the building is 2 or more stories in building height, every floor area is required to have access to a minimum of 2 exits, unless you comply with the exemptions. And in that case, you're typically a very small floor area. I don't think you can exceed a 15-meter travel distance to a single exit stair, which isn't always met. So that is why a minimum of 2 exits per floor are required, and also should one become inaccessible in the event of an emergency, you always have an alternate option. Then you have egress. Egress is provided from a room or a suite. So you determine the number of means of egress, doorways, provided from a room or a suite based on your occupant load, the travel distance, and the size of the room, depending on the occupancy. With regards to exiting, so as I said, an exit will always bring you outside to a public thoroughfare or somewhere that presents as a safe option. But the code does permit an exit through lobby scenario, where an exit may discharge into a lobby, conforming to the code, and then discharge you directly outside. Okay, so that lobby though, from the exit through the lobby, I need to reach the exterior of the building within 15 meters. The lobby floor has to be not more than 4.5 meters above grade. Adjacent rooms having direct access to the lobby do not contain care, residential, or residential occupancies. The lobby does not contain an interconnected floor space. The lobby is designed as an exit for all of the other requirements in section 3.4, except that rooms other than service and storage rooms are permitted to open onto a lobby. The fire separation is not required to have a rating, provided the lobby and adjacent spaces are sprinklered. So you would still have to apply a rating if you're in an unsprinklered building. And passenger elevators that open into the lobby must remain closed when not in use. Also, the door leading from the exit through the lobby is required to be equipped with panic door hardware and positive latching. A question came up as to what positive latching is. Positive latching just allows for a door to remain latched and closed in the event of an emergency to maintain the fire separation. Or let me back up. Positive latching is required on any door within a fire separation to maintain the fire separation at all times. That's typically why you have a closing device, or if you do have a magnetic hold open device, upon fire alarm activation, that magnetic will release and the door will close immediately to maintain a fire separation in the event of a fire emergency. Now I just want to back up for a sec because a question did come up about this one right here. So the lobby is designed as an exit in accordance with all the requirements of 3.4, except that rooms other than service and storage rooms are permitted to open onto a lobby. So if you look at the requirements for 3.4.4.4, so 3.4.4.4, integrity of exits, item number 8 states that this would be a requirement for an exit, in that storage rooms, washrooms, toilet rooms, laundry rooms, and similar ancillary rooms shall not open directly into an exit. Here it says that if you have an exit lobby condition, the lobby is designed as an exit, except that rooms other than service and storage rooms are permitted to open onto the lobby. This means that you could actually have a washroom or a laundry room open onto the lobby, and that would be okay. But if you have an actual exit, that would not be okay. Otherwise, you still can't have service or storage rooms open into your exit through lobby condition. This could also include a mail room. Sometimes cities and municipalities count mail rooms as storage, in which case such rooms would not be able to open onto a lobby. And that can become frustrating sometimes because a number of, especially residential applications, have mail rooms opening into lobbies, which are sometimes wanting to be designed as an exit through a lobby as well. Okay. So here's an example of an exit through lobby. So when I get out of the exit, I travel to the exterior within 15 meters. That's it. However, you'll also notice that in this image, there is a concierge desk. An exit through a lobby scenario cannot be considered an occupied floor area, contain furniture, plants, Nothing. It's literally spitting you out from a safe exit stair, enclosed from the remainder of the building, to another safe area, and then outside. You can't go from a safe place to an unsafe place, then outside. So typically, you can't have anything within a lobby. If you wanted this concierge desk to remain within an exit through lobby, your option might be to provide fire shutters that come down and separate it from the exit lobby in the event of an emergency. That's quite costly for wanting just to provide a concierge desk. Doors and door hardware. So doors are required to have a clear opening width depending on what occupancy they serve. Doors serving a room or suite having more than 60 people are required to swing in the direction of exit travel. They are not required to swing in the direction of exit travel if your occupant load is less than 60. Panic hardware required where doors serve an assembly occupancy with an occupant load more than 100. Sliding doors must have a breakaway feature when opening into a public corridor or used as an egress door in an access to exit. A question came up as to what breakaway feature was, and I'm just going to refer you to the actual requirement and I will read it to you. So requirements for doors are actually found in 3.3 as part of a means of egress. And it reads, so under 3.3.1.12 sliding doors, that's at the bottom of page 3.109, it states that a sliding door provided in locations described in 3.3.1.11, so serving for rooms or suites with more than 60 people or larger occupant loads or opening into a public corridor, etc., must be designed and installed to swing on the vertical axis in the direction of travel to the exit when pressure is applied, and be identified as a swinging door by means of a label or decal affixed to it. For instance, a lot of the time you find these types of sliding doors as part of exits on grocery stores or malls, in that there will be a decal affixed to it saying, in the event of emergency, door will swing open. So when you are exiting the building, again, in the event of an emergency, if you were to apply pressure, those sliding doors will now open on a vertical. Maglocks. Those requirements are actually in 3.4 as they affect exit doors as well. Maglocks required if desired to restrict access in direction of exit travel must be designed in accordance with 3.4.6.16, sentence 4. So typically you have a maglock on doors located somewhere within a means of egress that a client wants to keep locked during normal hours of operation or all the time. But because it's located as part of the means of egress, someone's access to an exit, they must open upon fire alarm activation or power loss, what have you. A lot of the time, any door equipped with a maglock will also be required to have a manual pull station adjacent to it or located within close proximity. And a lot of the time, depending on the province you're working with, and including the National Building Code, you require the door release hardware to open within 15 seconds of applying pressure. Why would you put a maglock on a door that someone can open within 15 seconds? Well, based on the intent of the code, you can't prevent someone from exiting the building. They have that right. And it's always in the direction of exit travel, but not into the office space. Exit stairs and ramps. So you're going to find all of those design requirements under 3.4 because they're applicable to exits. 3.4.3.2, 3.4.6.5. Even if you have a convenience stair, a hidden gem article that will serve you later is 3.3.1.14, and that's regarding ramps and stairways. So even if you have a ramp or a stairway that does not form part of an exit stair, they still need to comply with the requirements for exit stairs, and those requirements are listed in 33114. Otherwise, just generic exit stair requirements are found in 3.4. Those include having a minimum stair width of 1100 millimeters or 900 millimeters, depending on the type of building. Stairs have to have handrails on both sides if your exit stair width is 1100 millimeters or wider. If it's less than 1100 millimeters, you only require a handrail on one side. At least one handrail has to be continuous along the entire length of the stair, extend across intermediate landings, etc. The only time it can break is at newels or door openings, etc. At least one handrail must also have 300 millimeter horizontal extensions across the top and bottom of the top and bottom landing. The intent of that is to provide someone with additional stability and security when they are exiting or entering a stairway. Guards are required along stairs and ramps. If you don't have walls supporting either side or walls that are at least 1070 millimeters high, you will require a guard or other barrier that is 1070 millimeters high that extends along the entire stairway and landing. It used to be that guards could actually be lowered to suit the height of a handrail along a stairway. But as of the 2015 NBC, handrails now have to be, or guards have to be at least 1070 millimeters high along the entire stairway and the entire landing. Now guards must make sure that a sphere having a diameter more than 100 millimeters can't pass through. A lot of the time you just space picket the 100 millimeters on center to ensure that the 100 millimeter diameter sphere can't pass through. Now, they also cannot facilitate climbing, so the only horizontal components you can have within a guard are going to be less than 140 millimeters from the finished floor level, or stair surface, or ramp surface, or 900 millimeters above the finished floor level, ramp, or stair surface. Stairs have specific requirements for rise and run, and that can all be found in Article 3468. When constructed, you can have up to 5 to 10 millimeters in construction tolerances. Now, if the stairs should be designed so that an individual can easily go from one step to another, and that's why construction tolerances have to be so minimal to avoid tripping, slips, trips, and falls. If you want to have open risers between treads, that is permitted. However, the opening between the risers can't be more than 100 millimeters or be able to pass through a sphere with a diameter more than 100 millimeters, very similar to that of a guard. And that's just to ensure that if children are using the stairway, that they cannot fall through or climb through the stair openings. Now we're going to move into distance between exits. Distance between exits is based on the shortest distance smoke has to travel, assuming that smoke will not penetrate an intervening fire separation. So if we move to 3423, which is found at the bottom of page 3130, there's 4 sentences. So there's a couple options on designing for distance between exits. We're going to start with 1A and B. So 1A is that if you have a public corridor, the distance between exits is required to be at least 9 meters when served by a public corridor. In which case, if I did the diagonal dimension of this floor, okay, say it was 20 meters, divided by 2, I got 10 meters, then the distance between exits could be 9 meters. So it could be reduced by a meter, if you will. However, if you were to take the maximum diagonal dimension, which was like 8 meters, very small, divided by 2, gets you 4 meters. Those exits still can't be spaced apart any less than 9 meters. As for B, if a floor area does not have a public corridor, then you need to take the maximum dimension of the floor area and divide it by 2, and the result of that is going to be your distance between your exits. Now, we elaborated a little bit in this image in that the smoke travel was measured around tables, etc. But in reality, you would measure this distance as close to the wall, I'm not doing a very good job, but as close to the wall as you can, as smoke may hug that wall. Okay, it wouldn't extend that far, but you're getting the point, between the exits. So it would actually be like this, along the wall, down. Let's get a little closer there. And that would actually be how you measure distance between exits, of which could not be less than half the diagonal dimension of the floor area. If you have a floor area that is a weird shape, I think I have an example. Yes, I had it. Oh, here it is. So, say we have a floor area that's L-shaped. No public corridor. Distance between exits, how do you measure? You would measure from the furthest corner to the opposing furthest corner, whether or not that distance leaves the building. You would then divide that by 2, and that is the distance these exits would need to be spaced apart. If there was a public corridor joining these 2 exits, it would just have to be spaced such that the distance is not less than 9 meters per sentence 1A. There's a third option, which is discussed in sentence 2, in that exits need not comply with sentence 1, where the floor area is divided so that not less than 1/3 of the floor area is on each side of the fire separation, as indicated in this image, and it is necessary to pass through the fire separation to travel from one exit to the other. So as you can see, we have a portion of the floor area that's not less than 1/3, separated by fire separation, and we must travel from one compartment to the other in order to gain access to one or the other exit. There was a new one that came into play, which is sentence 4. The distance between 2 exterior discharges of exit stairs serving the same floor shall be not less than 9 meters apart or not less than 6 meters apart if the building is sprinklered, and the 2 exterior discharges are located within 15 meters of a street. In this case, say I have an office building, a residential building, any type of building, and some of the time what architects will do is that they'll have exit stairs placed in close proximity or not in close proximity, but then they will route them to exit side by side out the side of a building. In this case, based on this new requirement, such a design would no longer be permitted because the distance between the 2 exterior discharges would have to be greater than 9 meters or greater than 6 meters, depending on those conditions. Travel distance. The travel distance requirements, I believe, just on the next page, 3-131, are outlined in 3424 and 3425. Whew, here's messy. I didn't know. Okay. The distance from any point in a floor area to an exit is measured along the path of exit travel. Go figure. So, a sprinkled floor area is subject to a travel distance of 45 meters. High hazard industrial occupancy is limited to 25 meters to an exit. A group D that's not sprinklered is reduced from 45 to 40 meters. Other unsprinkled occupancies are limited to 30 meters. However, a storage garage conforming to 32290, which I believe is an open air storage garage, can have a maximum travel distance of 60 meters. So how do you measure travel distance? I typically will only measure travel distance in a building code review if I'm provided with a furniture or equipment layout plan. That's because then I can measure travel distance around the furniture to an exit to determine whether or not the travel distance is actually going to comply. If a client provides me with a drawing or you a drawing that has no furniture or equipment layout, then you have to measure the most restrictive travel distance, which is around walls, hugging walls, within almost a meter of them. In which case, you can extend your travel distance quite quickly by doing that. So you'd essentially or potentially be telling the client that they don't comply with travel distance, when in fact, once they have their furniture and equipment layout, they could comply with travel distance. It is just very helpful to have that criteria on the plan already versus backtracking. So yeah, you're going to measure from the furthest point of a floor area to an exit. Extending travel distance. So this was that item that I was alluding to when I was defining corridors used by the public. So sometimes one tenant will have a corridor serve them to achieve travel distance. How do you do that? So travel distance may be extended in a floor area by measuring from an egress door to an exit versus measuring from the most remote portion of the floor area to an exit, provided the suite or room is separated from the remainder of the floor area by a fire separation. So in this case, provided the suite or room is separated from the remainder of the building by a fire separation, seeing as this top corner suite, left-hand side, only has one means of egress, you would measure 25 meters to a single point of egress, and then you'd be given 45 meters from the egress door to an exit. This office space here, because there's two means of egress, we're permitted 45 meters to an egress and then 45 meters to an exit again. And that's how you extend travel distance in accordance with 3424 sentence 2. Alternatives to travel distance. So you don't have to comply with the requirements of 34251, provided a travel distance or provided exits are spaced along the perimeter of the building, not more than 6 meters apart, and that each main aisle within the facility leads directly to an exit. Okay, so you're almost creating a grid-like system. So all main aisles, primary aisle width, primary exit paths of travel, align with an exterior door placed 60 meters apart from each other, or not more than 60 meters apart from each other. A lot of the time, this type of travel distance is met in large industrial buildings or large storage buildings, sometimes even large retail stores like Walmart. What they'll do is they'll provide you a grid-like system in that whenever you're on a main pathway, it will lead directly to an exit door. Because from within the middle of those buildings, sometimes they're so large that you cannot make it to an exit within 45 meters. So egress from suite. Now we've talked about exiting, minimum number of exits, distance between exits. Now we're going to do the requirements for the minimum number of egress doors from a suite or a room. So provided all the following conditions are met, a suite is permitted to be served by a single egress door if the area of the suite is not exceeded as per table 3315A and B. So if we just want to flip our pages to 3315, sorry. wow, I really went too far. Okay, 3315. We will be on page 3-107. And now we'll show you tables 3315A for a non-sprinklered building and 3315B for a sprinklered building. The travel distance is not exceeded for table 3315A if unsprinkled, or 25 meters for a sprinklered building. And that is identified in 3315 sentence 1, clause C, subclause 1. And the occupant load of the suite does not exceed 60 persons. Okay? So I am right now sitting in a meeting room. Okay? I'll give you a little tour. Right? To my left is a single egress doorway. Okay? This meeting room is not sprinklered. I'm in a little industrial building. I'm a group B. I'm less than 200 square meters, less than 25 meters to that single point of egress, and less than 60 people. I think there's only enough chairs in here for 10 people. Which means this room in which I'm in is served by an adequate number of means of egress. It also swings inward, which is permitted because the occupant load is less than 60 people. Okay, let's do some more examples. Is this suite permitted to be served by a single means of egress? So we've got a travel distance that's less than 25 meters, actual 15. The group B office, not sprinklered, 150 square meters, there's only 16 people. Again, group B, we're less than 200, 15-meter travel distance, which is less than 25. Therefore, a single egress door is permitted. All right, 2 means of egress. A suite is required to be served by at least 2 means of egress. If the suite consists of an F1 occupancy, so your high hazard industrial occupancy, the occupant load exceeds 60 persons. For an unsprinkled building, the area of the suite or the travel distance exceeds that of 3315A. Sprinklered building, the travel distance exceeds 25 meters, or the area as allocated in 3315B. So we've got an example here. We have a travel distance that's greater than 25 meters, actual 35, to any egress door. Wink, wink, nudge, nudge. Group D office, sprinklered, 150 square meters, and there's 50 people in the space. So we look at 3315B. We got a D occupancy. We are less than 300 square meters. Sorry about that. We are less than 60 people, but we have a travel distance of 35 meters to a single, or to one of the 2 means of egress. Therefore, 2 means of egress are required. Perfect. So just to reiterate, say we have a sprinkler building group B, single egress. Here are the options. We need 25 meters to the single means of egress from within the room or suite. But we also need an overall 45-meter travel distance to an exit. Now, if the suite is separated from the corridor, you can measure 25 meters to the egress door and an additional 45 meters starting from the egress door to the exit. If there were 2 means of egress, you could have 45 meters measured to the single egress door, and then 45 meters re-begin at the egress door and end at the exit stair door. Okay? Perfect. So we've talked about distance between exits, and we've been talking about egress doors. So now it would only be fair to discuss distance between egress doors. So when you have a room or suite required to be served by two means of egress, those two means of egress need to be separated by 1/3 the maximum diagonal dimension of the suite. Do an example. So here's a floor area. The maximum diagonal dimension is 24. When you divide that by 3, then two means of egress need to be separated by not less than 8 meters. Okay? In this image, we're compliant. What happens if the doors are spaced closer than 8 meters apart? What we typically do is, in that case, we would have to construct walls of 0-hour rated fire separation so that the egress doors are separated such that smoke will travel around the walls constructed as smoke separations to achieve the distance between the two egress. A lot of the time this becomes apparent and required is when you have a large suite at the end of a corridor in a corner unit where you have two egress doors, one on this side and one on this side. So you'll actually create a fire separation along walls between those two doors. Okay, so now that we have discussed mezzanines and interconnected floor spaces, now that we've discussed everything that has to do with exiting and egress, we're going to move into mezzanines and interconnected floor spaces. So interconnected floor spaces are typically scenarios where there's breaches in floor assemblies, there's superimposed floor assemblies that are all interconnected with one another. That means stories are not separated from one another. And there's a few scenarios that can include that. So an atrium, large openings like in this image, and then you have mezzanines. A mezzanine is essentially a raised floor within a floor area or story. So if we go to interconnected floor spaces again, interconnected floor spaces are connections between stories. Okay, so one story is open to another story. A mezzanine is just one story with a raised floor area within it. So it has no effect on building height. So we're going to go through the requirements for a mezzanine. The requirements for those you can find at the beginning of your 322 articles, essentially. It's right at the beginning. It's 3211. And here you have options, okay? So the way it works, mezzanines can either be open or enclosed. Open or enclosed, all right? So the open option is discussed in 3211, sentence 3. In that, a mezzanine is permitted to remain open provided it occupies less than or equal to 40% of the open area of the room in which it's located. The space above remains open, but spaces below it can be enclosed. Once you enclose areas below the mezzanine, you have to reduce that from the open area of the room in which it's located. Okay? Because the 40% has to be the open area of the room in which it's located. So any enclosed rooms within that floor area must be subtracted because it's not the open area of the room. So now, an enclosed mezzanine, so if you don't comply with the requirements of an open mezzanine, then we move into sentence 4. This permits you to have an enclosed mezzanine. However, it can't be more than 10% of the floor area or story in which it's located. So you don't have to reduce those enclosed areas as you would for a 40% open mezzanine. The space can be fully enclosed and there's no requirement for visual communication. Okay? So this is the same thing, but a second example of enclosed mezzanine. Again, you can have one mezzanine that's enclosed, which is less than 10% of the floor area or story in which it is located. However, you can, if that floor area or story is divided into rooms and suites, and you want additional enclosed mezzanines, each mezzanine within a room or suite is not permitted to be greater than 10% of the floor area of the room or suite in which it's located. And the aggregate area, so like if you have multiples, now I have two, the aggregate area of these two combined must be not more than 10% of the total floor area or story in which it's located. And then there's a third option, which is covered under 322 or 3211 sentence 7. So we can go back to the option we discussed at 1 with an open mezzanine, so 40% open mezzanine. However, on that 40% open mezzanine, I can have a 10% enclosure, which is 10% or not more than 10% of the floor area in which it's open to. So we have a 40% mezzanine, 40% of the open area in which it's located, and then on top of that 40% mezzanine, we can enclose a portion which is 10% or not more than 10% of the floor area or the open floor area in which it's located. You're not going to have 40% and then another 10% to make 50. It's not the case. It has to be within the 40% open mezzanine. However, here in Alberta, Calgary, the city has a very weird interpretation in that the enclosure can only be 10% of the size of the 40% mezzanine. That's not the case. The literal application of the code states that you have a 40% mezzanine, which is 40% of the open area of the room in which it's located, and then on that 40% mezzanine, you can have an enclosure that is not more than 10% of the open area of the room in which it's located. Walls must not block the view, so I need to have perfect communication from the top to the bottom and from the bottom to the top. If this had a pathway at the back here and the front portion was enclosed, this would be visually obstructed, which is not permitted. Mezzanines can also be in the form of catwalks or service spaces, in which case this wouldn't play a role in building height either. If it is considered a catwalk or a service space, and the mezzanine won't be used for any other purposes other than maintenance, those are actually permitted to have an extended travel distance of 50 meters under 3424. Meanwhile, all other mezzanines have to comply with the egress requirements of 3422. So why are egress requirements in 3.4 when I said earlier that 3.4 only applies to exits? Is that because of the first sentence, number 1. So on page 3-130, under Article 3422, it reads, space above a mezzanine shall be served by means of egress leading to exits accessible at the mezzanine level on the same basis as floor areas. The means of egress from a mezzanine need not conform to the requirements of exit, provided you meet the following criteria. And that means the mezzanine is not required to terminate at a vertical fire separation. Document load is less than 60. You have an area and a travel distance within the parameters of table 3422. And if you meet that criteria, then your mezzanine can be provided just with an open egress stair, similar to that of an egress door serving a room or suite. If your mezzanine does not meet those requirements in sentence 2, then you are subject to provide enclosed exits in accordance with 3.4 directly from the mezzanine level. Now, if you read sentence 3, it says at least half of the required means of egress from a mezzanine shall comply with sentence 1 if the mezzanine is not required to terminate at a fire separation as permitted by 3282. So if you don't comply with sentence 2 and you need exit stairs, one of those exit stairs is required to remain open provided the mezzanine is not required to terminate at a fire separation. Okay? Easy enough. Now, someone had made a comment regarding whether or not the means of egress from a mezzanine is required or is different for a sprinklered mezzanine versus a non-sprinklered mezzanine. All mezzanines are treated the same for egress and exiting requirements. The requirements applicable under sentence 2 and in table 3422 are actually identical to the means of egress requirements serving a room or suite that is not sprinklered. So it's actually more restrictive on a building that may be sprinklered. Now we're going to get into interconnected floor spaces. So this is when one story is open to another story or multiple stories. Okay, so there's two conditions. These conditions are in 3282. Oh, let me just go back for a second for the egress. So as I was stating, you can determine whether or not your mezzanine is required to terminate at a vertical fire separation under Article 3821 and Sentence 3282, Sentence 1. So if you want to determine whether or not you can enclose one of your exit stairs or whether or not your mezzanine is required to terminate at a vertical fire separation, those answers will be provided to you in 3821 and 3282, Sentence 1. From there, we get into the requirements of interconnected floor spaces. So I'll be on page 3-103, and right now we're going to look at the first two conditions, which are discussed in items 5 and 6. So the first condition is that you can have an interconnected floor space between the first story, remember the definition of a first story, and the second story above, or the first story and the story below, so like the basement level, if you will. However, you can't have all three of them. Otherwise, that's non-conforming, and you would have to comply with the remainder of the requirements in 3283 to 3288, and those are not fun to comply with. In order to comply with this first condition, so first story, second story, or first story and the story below, the IFS opening can only be used for stairs, escalators, or moving walks, or just be like an open atrium. The presence of stairs is not required provided the building is sprinklered. The IFS has to be sprinklered throughout, and it contains an A, D, E, F2, F3 major occupancy. So an interconnected floor space conforming to this first condition would not be permitted in a group C or B occupancy, so a residence or a care facility. Now you get into the second condition, which is outlined in sentence 5. Any number of stories can be connected by open stairs, so like a convenient stair, an escalator, or moving walkway, provided the following conditions are met. The opening for the convenient stair, escalator, or moving walk is not greater than 10 square meters. So if you look at this image, that opening for the escalator is not going to be greater than 10 square meters. The entire building is sprinklered, and it can only be used in an assembly, office, or mercantile establishment. So you could not use this or interconnect multiple stories with a convenience stair in a residential building or a care occupancy or any of your hazard industrial occupancies. Okay? So all floor assemblies of floor areas or mezzanines must terminate at an exterior wall of verticals or a vertical fire separation or a shaft of some sort. If not, they have to be protected against smoke, flame, and heat movement as per the items in 3283 to 3288. Now, these requirements just stipulate that the building needs to be sprinklered throughout. If you can't conform to the first and second condition, you would need vestibules at each level for exits opening directly into an interconnected floor space, or to protect the elevator door openings in the interconnected floor space or the elevator door opening into stories above the interconnected floor space. So you would actually incorporate these vestibules to almost separate your interconnected floor space from the protected area that allows individuals to exit the building. This protected floor area is used to ensure that people are safe and out of harm's way from the interconnected floor space that might be filled with smoke in the event of an emergency because of the interconnected floor spaces. But in this case, because of the vestibules and the fire separation between the two, we are allowing for safe exiting from the floor area without having to travel through the interconnected floor space. Interconnected floor spaces are also required to be accompanied by draft stops, which are these that surround the openings and can't be less than 500 millimeters deep, measured from ceiling level down to the underside of the draft stop. Typically, draft stops also have to comply with NFPA 14, or NFPA 13, sorry, the sprinkling one, in that you also need closely spaced sprinklers adjacent to the draft stops, and that will create a water curtain effect so that the smoke can't travel from one floor to the other floor. In NFPA 13, though, it does discuss eliminating the need for draft stops once the opening gets to a certain size. However, in the code, it stipulates that all openings need a draft stop, but that is kind of an oversight because once an opening gets very large, a draft stop isn't going to mitigate smoke from passing through one floor to the other. Whereas in a small opening, such as these ones shown in the images, a water curtain will provide a significant effect in reducing the amount of smoke traveled between floors. You need to also consider a mechanical exhaust system if you can't conform again to items, the first condition and the second condition, and you would also need to consider the amount of combustible content within the floor area. I'm going to be completely honest here and let you know that I have worked on thousands of projects, and I don't think I've ever worked on one where they actually complied with each of the requirements from 3283 to 3288 if they didn't meet the first and second condition. A lot of the time what will happen is they will want to seek compliance through an alternative solution or a variance, where we would do a performance-based analysis to ensure that the performance level of the interconnected floor space will be safe in the event of an emergency. In the past, we've done computer modeling that included analyses for passive air systems, mechanical extraction, smoke extraction systems, as well as fire shutters, fire curtains, to separate floors from the interconnected floor space in the event of an emergency. And in a number of cases, those alternative solutions have been accepted to omit buildings from having to comply with 3283 to 3288, which can have a serious effect on the architectural aesthetics that are trying to be achieved of a building. Now we're going to get into fire alarm and provisions for firefighting. So you can flip to 324 and 325. So under 324, it'll tell you where a fire alarm system is required and when it is required. When it is required, if your building's sprinklered, it's an easy, yes, I need a fire alarm system. Otherwise, if you're a non-sprinklered building, there's a number of scenarios where you would require a fire alarm system, such as if you're more than 3-story building, you have more than 300 people, you're a restaurant and you have more than 150 people. Otherwise, all of these are outlined in NBC 3241, which can be easily identified to determine whether or not your building needs a fire alarm system. Now, there's two types of fire alarm systems. There's a one-stage and a two-stage. So one stage can be used in all buildings or in B3 occupancy, so care occupancy is less than 3 stories in building height. A two-stage fire alarm system can also be integrated into all buildings, but are required in all B occupancies, with the exception of B3 occupancies less than 3 stories. So the difference between the two is that a one-stage fire alarm sends an alarm signal to an audible device in the system immediately and encompasses the entire building. So once a full station is pulled, a fire alarm will go off and everyone will evacuate the building. Very simple system. Whereas a two-stage fire alarm system will emit an alert signal so that someone can go investigate that zone to see whether or not it's a false alarm. If it's not acknowledged within 5 minutes, then an alarm signal will sound and people can start to evacuate the building. The purpose of a two-stage fire alarm system within a care occupancy mainly is so that you don't interrupt people. And if there is a false alarm within a certain zone in a hospital, someone can go investigate first, determine the circumstances. If it is an emergency, they can put it into alarm mode. Or if it's not emergency, they can just deactivate the fire alarm system, and then no one else would even know that an issue or the fire alarm was activated within its first stage. This is primarily also very important in establishments where you have care wings, people with dementia or memory care units, in that if a fire alarm were to go off in the building, this could put people in a confused state of mind. They could feel panic and confusion, and it wouldn't react well. Whereas in the event of a two-stage fire alarm system, if the fire alarm is pulled, one of the care attendants can go investigate the scenario and then deactivate it so that no alarm is set off, or set the alarm and then have the measures put into place to safely evacuate those individuals from one compartment to another compartment, or from one compartment outside to a safe place. Provisions for firefighting. So this can all be found in 325. I'm not going to go too much into detail here, only because they are pretty straightforward. So if you have an unsprinklered building, you need to provide firefighters with access to the above grade stories and to basement levels. Whereas in the case of roof access, if your building is more than 3 stories in building height, where the slope of the roof is less than 1 in 4, all main roof areas need to be provided with direct access from the floor areas immediately below, either by a stairway or a hatch with a fixed ladder. Access routes for fire department vehicles are required to be provided for all buildings more than 3 stories or more than 600 square meters in building area. This is the silliest requirement ever, in that all buildings, no matter what size, no matter how many stories, all need to be accessible by fire department personnel. An access route must be designed in conformance with a number of design requirements, in that they have to be larger than or wider than 6 meters. They need to be able to support a fire truck in all weather conditions. So that may take into consideration a stronger or larger granular material. It needs to be connected to a public thoroughfare. There's also requirements relating back to center line radiuses, turnaround requirements, etc. But they're all listed accordingly in Article 3256. Then you get into 32210 and 3255, which address sprinklering requirements for the building. You need one access if it's sprinklered, and then you need access to 1 to 3 streets if you're not sprinklered. Where can you determine how many streets? That is also addressed in 32210 or your 322 article that we learned how to use earlier on in this webinar. Now, a standpipe system, and those requirements are outlined in 3258 to 32511. So same section that we're in. And a standpipe system is required in a building more than 3 stories in building height, or where the ceiling of the top story is more than 14 meters above grade, or where the building area exceeds those specified in table 3258. Now, the standpipe design must comply with the code, but it also must be designed in conformance with NFPA 14. So hose connections are required to be provided to firefighters and are permitted to be located within exit stairs along with the risers. You would not require fire hose connections within floor areas where the building is sprinklered. If the building is not sprinklered, then you would require hose stations within 5 meters of exit stairwells. If you're working on a building, again, potentially in Ontario, the OBC requires that no matter what, sprinklered, unsprinkled, that you have a fire hose cabinet with connections located within 5 meters of the exit stair. So an alternative solution would actually be required if you wanted to comply with this type of design, where you have the riser and the connection located within an exit stairwell. Note, those connections and the riser must be located on the main levels. They cannot be located on the intermediate landings. But also to that point, when you're doing an alternative solution or a variance, one of the criteria you could use is proposing to meet the requirements of another code. In this case, when we do alternative solutions for standpipe systems in buildings in Ontario, we would be arguing that it comply with the National Building Code and the NFPA 14 guideline. Okay, so now we're going to talk about commissioning. This is a relatively new term and topic, which is sparking a number of conversations in the building industry, especially those that install systems, test systems. And this is related to integrated fire protection and life safety system. Essentially, it just states that where fire protection and life safety systems and systems with fire protection and life safety functions are integrated with each other, they shall be tested as a whole in conformance with CAN ULC S1001. So typically, what used to be done, or what is a common occurrence, is that every sub-trade installs their system, so the fire alarm system, the mechanical guy installs the mechanical system. Once they've installed their system, they test their system, put a check mark in the box, and say that it operates accordingly. But no one ever thought about testing the fire alarm in conjunction with the mechanical system to make sure that they operate cohesively in the event of an emergency. So the whole point of commissioning is to verify that these systems work together and there is proper operation and interrelationship between the systems. High building requirement. So now we're going to move into 326. We're going to go back a couple pages. And we're going to learn how to classify a building as a high building. Okay? So we are looking at page 3-96 under Article 3261, Sentence 1. Okay, so the building code outlines 4 determining factors for high building classification. It's actually 5 when you break them down. So height of building. So a building is considered a high building when the height of the building is greater than 36 meters from grade to the floor level of the top story. And this is applicable to an assembly, an office, a mercantile, and a industrial hazard building. So that is measured from grade to the top of the floor of the highest floor level. Okay, not the roof, not the ceiling, the floor level of the top floor. Your second condition, high occupant loads on floor areas in buildings over 18 meters in height measures between grade and the floor level of the top story. This is also applicable to A, D, E, and F. That's why it's considered and lumped under one determining factor. So in this case, if we do the calculation under sentence 1 subclause 2 and we're determined that this is a high building based on occupant load, it's more than 18 plus meters between grade and the top of the floor of the top story, then we are deemed a high building. Okay. So in the other circumstances, on this one I put 5. Okay, so if you have a group B occupancy, okay, group B, with its top floor more than 18 meters above grade, it's deemed a high building. If we have a patient care occupancy, so B2 or B3, above the 3rd story, no matter the height, as long as it's above the 3rd story, that too is considered a high building. This goes back to when I was discussing the importance of determining your first story. Say this story on the bottom here was half above grade and half below grade. If you figured that it was more below grade and just called it your basement level and then labeled this one as your main floor, and you had a B3 occupancy on your 3rd floor, then you wouldn't be a high building. But if someone were to go back and check and do a grade analysis and determine that this level is in fact the 1st story based on the definition, you would now be considered a high building because you have a B3 occupancy above the 3rd story. And the last item that classifies a building as a high building is any building consisting of a group C occupancy whose floor level is more than 18 meters above grade. Pretty simple. Okay, so if you want to determine whether or not your building is a high building based on an occupant load, you need to add up all the occupant loads for the floor levels above the 1st floor. You need to determine the aggregate width of meters of all exits serving each of the floor levels above the ground level. You need to divide the total occupant load for the building by 1.8 times the aggregate width of exits. And then if the resulting value is over 300, the building is deemed a high building. So I've outlined some criteria here. And I've given you a starting point with the calculation that you would do. So your 5th and 6th floor have 2 exits at 1100 each. Your 3rd and 4th floor have 2 exits at 1200 millimeters each. And then your 2nd floor has 4 exits at 1200 millimeters each. Again, you don't include exits on the ground floor level. I've incorporated the occupant load for each floor level, but in your cumulated, if you're in your accumulated occupant load, so your 6th floor is 149 because there's no one above you. But then when I get to the 5th floor, I'm going to be adding 149 to 142 for the 5th floor because now I'm traveling from the 6th floor down to the 5th floor and I'm picking up that occupant load. Okay, that occupant load is then going to be accumulated with the 4th floor occupant load of 164 because we're all traveling down. Now we're picking up the occupant load on the 4th floor, and then so on for the 3rd floor and the 2nd floor. Then you're going to use that number in the calculation, and if any of these results end up in 300, you are considered, or that building is considered a high building. So if you go through and do these calculations on your own to make sure you're comfortable doing them, and you will realize that the result is less than 300 for each of the floor levels, therefore this building would not be considered a high building. Now, if you did get 300 as a result, and the client really didn't want to be deemed a high building because they don't want to comply with all of those additional measures under 326, then you could recommend widening the exit width of the stairs on 1 or 2 of the levels, or until you get to a point where that 300 is no longer a value in your result. Because the wider the stairs, the more people it can accommodate. When it comes to high buildings, you need to apply additional safety measures within that building. You need to limit smoke movement between floors. You need to limit smoke movement within stair shafts, below grade, above grade. And you also need to look at smoke movement within shafts serving your building. So the main item is really protecting the exit stairs on the lowest exit level and exit stairs above the lowest exit level. So exit stair serving levels above the lowest exit level require a vent or a door to the outdoors at or near the top of the stair shaft to release smoke. And then stair shafts serving stories below the lowest exit level are to be separated from the stair shaft serving stories above the lowest level, right? So you're going to have the below grade stairs separated from the above grade stairs. The stairs below the lowest exit level and separated from the above grade stair are required to be pressurized. If you have connected buildings, so links, those links are either going to be pressurized or you're going to have vestibules upon entering each end of the link that are pressurized. Or if this link were open to the exterior elements, then you would just have a fire separation on either side. Again, this is to protect smoke traveling from one building to another in the event of an emergency. You also need to consider emergency operations of elevators. So you would need a firefighter's elevator, and that you would need a recall level for all of the elevators. So in the event of an emergency, all elevators will recall or relocate to one level. That level is typically the same level as the principal firefighter's entrance with the CACF room. Your CACF room is your central alarm and control facility. A CACF room is required to be provided and located close to the principal entrance. When we say close, fire marshals typically want the CACF room within the entrance vestibule or the principal entrance vestibule. If you can't put it in the entrance vestibule or for security reasons, for whatever, then you can place it up to about 15 meters from that vestibule. Buildings are required to have a voice communication system should the top story be more than 36 meters above grade, or where there is a group B2 or B3 occupancy above the 3rd story. Again, very similar to the commissioning requirement in 329, the systems for control of smoke movement and mechanical venting are required to be tested to ensure a satisfactory operation. Okay, now we're going to move into occupant load and exit capacity. The number of persons for which a building or part thereof is designed. Occupant load can provide answers to a number of things. It can determine your exit width, it can determine your number of water closets, whether or not you require a fire alarm system, the type of emergency lighting and exit signage required, whether or not you're building a high building. It also dictates door swing. It really does tell you a lot about a building. When calculating occupant load, you want to take into consideration the number of fixed seats. For example, if it's an assembly occupancy, you're permitted 2 persons per sleeping room in a dwelling unit. And under 3.117.1, which we can find on page 3-36, sorry. So you have 2 options. Under sentence 2, it says, if a floor area or part thereof has been designed for an occupant load other than that determined from table 3.117.1, a permanent sign indicating that occupant load shall be posted in a conspicuous location. So you can either determine your occupant load by taking your floor area and dividing it by an NBC factor as seen in table 3.117.1, or you can choose your own occupant load that is greater than what is determined by your NBC factor, but it has to be posted on a sign in a conspicuous location. For calculating occupant load, you just need to measure the floor area, determine the use and occupancy of those floor areas, so make sure that you're applying the correct NBC factor, and then you simply divide the floor area in square meters by occupant load factor. So here's an example. We have a group B office space, we have a floor area of 1,400 square meters, and we have a building core of 240 square meters. The building core is essentially your mechanical elevators, your stair shafts, and your building service shafts. If you want clarity on this, then just look up the definition of floor area to determine what you can subtract from that. So you would take your floor area of 1,400 square meters and you would subtract your building core to get your floor area, your occupied floor area, and then you would divide that by your NBC factor that you find in table 3.117.1. So in this case, we have 1,400 minus 240, which equals 1,160 square meters, or 1,160 square meters. When we divide that by a 9.3 square meter NBC factor, which is found again in table 3.117.1 for business and personal service uses, not the personal service shops one, the offices one, which shows 9.3. I'll see if I can find it's one of these, the 9.3. When you divide 1,160 by 9.3, you get 124.7, so you're going to round up to 125. So now that we have our occupant load calculated by the NBC factor of 125, we need to determine whether or not the exit capacity is sufficient to support that occupant load. So when determining the minimum width of exits, you simply go to 3432 and you apply the NBC factor for exit width. Now you can divide it by 3.1 millimeters per person for ramps, doorways, and corridors. Typically you'll use this if it's an exit door exiting from the ground floor level. You'll use 8 millimeters per person if you know the design of the rise and the run of stairs. Otherwise, you'll use 9.2 millimeters for all stairs because that's the worst case scenario. Rarely do we use 8 millimeters unless the client has given us the design criteria for the stair, or we've done a site visit and we know that the rise and run is 180 by 280, or we're provided with stair drawings and we can check that ourselves. But for the most part, you use the worst case scenario. And then you would apply 18.4 millimeters per person for anything serving a Group B or care occupancy. Most restrictive element determines maximum exit capacity. Any single exit cannot contribute more than 50% of the required exit capacity. This means that if you have 2 exit stairs, one at 900 millimeters wide and one at 1100 millimeters wide, when you're calculating exit capacity, you can only treat both exits as if they were 900 millimeters wide. Okay? If you have 2 exits at 1100 millimeters wide, then you calculate both exits at 1100 millimeters wide. Calculating exit width. Once you have more than 2 exits, it doesn't matter. Then you would use the individual exit width for each of the exits, divided by its appropriate NBC factor. So same floor area, it's served by 2 exits at 1100 millimeters each. We're going to again go with the most restrictive, which is 2 times 1100 millimeters divided by a factor of 9.2 millimeters per person, which gives us 239. So you're going to get 239.1, I believe, when you calculate this. So you're going to round down because you already have exit capacity there, and you can't accommodate that 0.1 of a person. Okay, so occupant load up, exit capacity down. Now we're going to calculate plumbing fixtures. Water closets are to be provided assuming the occupant load is equally divided between males and females. Urinals are permitted to be substituted for 2/3 of the required water closets, and you need at least 1 lavatory for every 2 water closets. So design and location. The code just stipulates that washrooms are required to be made available for all occupants of the building. However, washrooms need to be provided on the same floor level as the occupants they are intended to serve, provided that all occupants within the building have access to the washroom facilities. In this case, you could have a large college. You would calculate all the number of water closets for the entire facility, of which you could lump in the basement in the bottom corner somewhere, and everyone could use them that way. However, that is not practical nor convenient. So you would take the total number of water closets and you would distribute them throughout the building to be more conveniently placed to serve the occupants of the building. Now, if we have a scenario where we have like a high-rise tower, office tower, and each floor consists of a separate tenant and there's security breaches between those floors, so like I can't go to the second floor and use those washrooms because there's security in place, so there's a swipe key, swipe card, etc. Then I need to be providing washrooms on each floor level, accessible to each tenant on those floor levels. Any shelf or projection above a lavatory is not permitted to become a hazard. So you really need to watch the placement of shelves within bathrooms because they can become quite a hazard to individuals with vision impairments. Location and design. Washrooms are required to be, again, the last note. This is not an NBC requirement. I believe it once was back in like 1980. But besides that, it's since been deleted, but has been incorporated into other provincial building codes across Canada. And that is that where a washroom contains more than 1 water closet, more than 1 lavatory or a shower and a bathtub, the doorway to that bathroom is not permitted to be situated such that a person standing at the door can see a water closet, can see a lavatory, a shower, or a bathtub. Okay? And that should just be good design practice in that if you're going to the bathroom or you're washing your hands or you're having a shower, some stranger standing at the entrance of the door should not be able to see you doing those things. Under 3729 in the health requirements section, you'll notice there's design requirements for a bathtub. If there's requirements that it has to be barrier-free, then you should also be referencing 38316 to 38317. In the meantime, we're going to work on a water closet calculation. So we're going to flip to section 3.7. And we're going to look at table 3722B, which is on page, if I can find it, 3158, as displayed on the screen. Now we're going to use the same floor area we calculated occupant load for. We have a floor area divided by NBC factor. Okay, so again, same floor area. We take 1160 square meters. We divide by 9.3 square meters, which equals 125 persons, because we round up. We divide that by 2. We again get a decimal, so we round up, which gives us 63 male and 63 female. So if we refer to our table here, we are over 50, which means we require 3, and then it reads +1 for each additional increment of 50 persons. Because we're only at 63, we don't need to add an additional one because we're not at an additional increment of 50 yet. So that means we would require 3 male and 3 female water closets, of which 2/3 of those male water closets could be substituted for urinals, and we would need at least 2 lavatories per washroom. Oh, I do want to confirm one item if it wasn't clear for the exit capacity and occupant load. In that, when we did determine our exit capacity of 239 persons, because it is greater than the calculated 125 persons, the exit capacity is sufficient to support the occupant load in accordance with the code. Okay. Now, if you wanted to have an occupant load greater than 125, your client says, well, I want to put 200 people here. You would be permitted to put 200 people in the floor area because your exit capacity is still 239. So if you wanted, you could actually post your exit capacity of 239 rather than your anticipated occupant load of 200%. And again, that reverts you back to that sentence 3.1.17.1, sentence 2, which permits you to have a different occupant load than what you calculate using the NBC factor, provided you post a sign. Okay, so back to washrooms, we were required to have 3 male water closets, 3 female water closets. If you look at this plan, there's actually 4 water closets per washroom, which means this floor area is served by adequate washroom facilities in accordance with the code. Now we're going to get into protection of floor areas with a barrier-free path of travel. In other words, areas of refuge. So section 3.8 provides guidance toward designing barrier-free accessibility through a building. And section 3.8 also addresses the well-being and comfort of persons with disabilities within a building by providing design criteria to suit that of people with wheelchairs, cognitive disabilities, sensory disabilities, etc. Vision as well. So nowhere in section 3.8 though does it address the safety of individuals with varying levels of abilities. So that information can only be found in Article 3317. So there's various approaches to complying with protection of floor areas. The major one, so protection of floor areas is deemed to be provided if your building is sprinklered. So if I was a wheelchair user or I had a disablement or an impairment that prevented me from exiting the building like an able-bodied person could in the event of an emergency, the sprinkler system is intended to, sorry, the sprinkler system is intended to protect me. I had a slight giggle there because I think it's absolutely ridiculous that a sprinkler system is said to protect an individual with a disability when everybody else is evacuating the building. Whereas if you are an unsprinklered building, there are many other options that you have to comply with, and that is provide a pressurized elevator, or fire separate the floor area into fire compartments. So that way, in the event of an emergency, an individual with a disability can actually go into a compartment that is protected from the remainder of the floor area and hopefully the fire hazard. So that way, in the event of an emergency, a firefighter can come up, save me from an already safe spot, and then help me evacuate the building. But in the event that my building is sprinklered, I could just be sitting in the room I was originally in. I could be in a public corridor. I could be anywhere. But that's not to say that those areas won't be affected because they're not protected or compartmentalized. In the case of a residential building, you can have a balcony provided off of your dwelling unit, and then just providing exit options from the ground level. Okay, so this is getting into the last component of our seminar today, and that is barrier-free design and accessibility. So this discussion will take place using section 3.8, starting on page 3161. Now, entrances, not less than 50% of entrances into a building are required to be designed barrier-free. Round up if not a whole number. Walkways and bridges that connect barrier-free stories must also be barrier-free. A barrier-free path of travel is required from an accessible parking space to a designated barrier-free entrance to and throughout the normally occupied entrance story, and to and throughout all normally occupied floor areas that are served by an elevating device. The funny thing is, if you have a 2 or 3 story building that is exempt from barrier-free requirements on the 2nd and 3rd floor, the entrance story is required to be barrier-free, then you voluntarily provide an elevator to the 2nd and 3rd floor. That 2nd and 3rd floor are now subject to the requirements of section 3.8, whether or not you voluntarily provided it. If you just go along with the code requirements and you're exempt from a barrier-free path of travel to the 2nd and 3rd floor, if there's no elevator to those floor levels, you would not need to comply with section 3.8. Access to parking. So you need exterior parking, you need access to 1 level of indoor parking. Be careful with this one, depending on the municipality or the city you're working within, depending on the transportation bylaws, they might actually have more stringent accessibility parking requirements, which could require inaccessible parking spaces on more than 1 parking level. But in terms of meeting the minimum requirements of the code, you just need access to 1 level with indoor parking that has accessible parking space on it. Now, if there's a passenger loading zone, it needs to comply with the applicable criteria. And then in Appendix A, there's an explanation or explanatory material that provides you with more guidance on the design of accessible parking spaces, which is said to align with the general requirements across Canada. And that's why, again, I would prefer that you do reference the transportation bylaws for whatever project you're working on, in that across Canada, accessibility standards for accessible parking spaces vary very widely ranged. So a barrier-free path of travel is required to all buildings with the exception of houses, your F1 facilities, temporary industrial accommodations, pump houses, etc. The barrier-free path of travel is also not required to service rooms, janitor rooms, attic or roof spaces, and then mezzanines not provided with a passenger elevating device. A barrier-free path of travel is required to be not less than 920 millimeters wide. Now, you have to remember that all aisleways are required to comply with the National Fire Code in that they must be not less than 1100 millimeters wide. If you have a subsidiary aisle that branches off of a primary aisle for not more than 7.5 meters, that can be reduced to 900 millimeters. In which case, if it's forming part of a barrier-free path of travel, that subsidiary aisle would have to be 920 millimeters. I think the requirement you just need to know here is, like, if it asks you specifically for width of the barrier-free path of travel, you would answer 920 millimeters, when essentially all primary aisles throughout a floor area have to be 1100 millimeters to comply with the code. I provided a diagram here. So typically 920 will permit a passage of one wheelchair user, whereas 1100 millimeters is said to permit the passage of a wheelchair user and a passerby. That is not the case at all. With any average individual walking past an individual with a wheelchair, you're usually looking at about 1500 millimeters. Anyway, a barrier-free path of travel needs to include ramps, elevators to overcome changes in elevation. You need to be stable, firm, slip resistant, and make sure that thresholds are no higher than 13 millimeters and beveled. If you've ever tested out a wheelchair yourself, you'll know that 13 millimeter thresholds can be quite difficult to maneuver over. So it is recommended that you try to keep them level or flush with the floor level as much as possible. In a barrier-free path of travel, you require lay-by space when the travel distance or when the path of travel is greater than or longer than 30 meters. That lay-by space has to be not less than 1.5 meters by 1.5 meters and is required at 30-meter intervals. When you have a ramp in a barrier-free path of travel, it's required when your floor is sloped greater than 1 in 20. It needs to have an adequate landing at the top and bottom of the ramp. It needs to be served by handrails on both sides, guards on both sides, and all of this design criteria can be found in 3835. Accessibility signage displaying the international symbol of accessibility must be provided to identify your barrier-free entrances, accessible washrooms, accessible showers, accessible elevators. Typically, it's the elevator that conforms with CAN CSA B44, Appendix E of the Safety Codes, elevators or safety code for elevators standard, if I recall correctly. Accessible parking facilities and facilities for persons with hearing disabilities. Any accessible facility should be provided with accessibility signage or directional signage indicating where that accessible facility is. Controls for the operation of building services or safety devices intended to be operable by building occupants are required to be operable with one hand and located between 400 millimeters and 1200 millimeters above the finished floor level. When you get into doors and doorways, so a door has to have a minimum clear width of 800 millimeters, and this is measured between the inner face of the door and the inner stop of the frame, or the innermost latch. Whatever closest component within a door, that is your clear width. Hardware needs to be operable with a closed fist and mounted between 900 and 1100 millimeters. Unless equipped with a power door operator, you need to provide adequate latch side clearances, and that's 300 millimeters on the push side and 600 millimeters on the pull side, and that's to ensure that if I am in a wheelchair, I can maneuver a door without being obstructed by the door swing. Each door also needs to be equipped with a level door maneuvering clearance on each side. I don't want to be rolling away from the door as I'm trying to open it. And that needs to be the same width as the door plus the latch side and as deep as the barrier-free path of travel serving the door, but doesn't have to exceed 1500 millimeters. For you have vestibules, you need a 1200 millimeter distance in between two doors in series. And in the explanation material in Appendix A, just located right at the back of Part 3, you can find these nifty images that actually describe how you would measure clear width of doors, depending on whether or not there's an exit device or no exit device. It shows you how to measure latch side clearances, etc. Assembly seating. So when you're designing a theater or a lecture hall, etc., you need to take into consideration designated wheelchair seating. It needs to be part of the seating plan. It cannot, the seats can't obstruct an egress path of travel. They must adjoin a barrier-free path of travel. And you might even have to take into consideration an assistive listening device or system, depending on the size of the lecture hall or theater or assembly space, etc. Typically, you're always going to have at least two designated wheelchair spaces, and those spaces need to be side by side. Typically, you want to also situate them so that they have companion seats on either side of them. They need to form part of a barrier path of travel. They can't obstruct an egress path of travel, and you want to make sure that there is a choice of viewing. So if you have more than one tier, you'll have to provide a barrier path of travel to more than one tier. Washrooms required to be barrier-free. So as per the little application, all washrooms have to be barrier-free. Where water closets are required by subsection 372, so required by the health requirements under 3.7, at least one barrier-free water closet is required to be provided in the entrance story unless a barrier-free path of travel is provided to barrier-free water closets elsewhere in the building, or they're for dwelling units only. Where alterations are made to the existing facility, universal washrooms are permitted in lieu of multi-stall washrooms. Now, washrooms that are not required to be barrier-free, so these are exempted from, they have to be located in residential suites or care suites. Only barrier-free washrooms or other barrier-free washrooms are located within 45 meters of another washroom. So if I have a universal washroom located within 45 meters of another washroom, then these washrooms would not have to be barrier-free. Okay? Or they are located in an individual suite serving a group B, E, or F less than 500 square meters and completely separate from and without access to the remainder of the building. So all of your barrier-free washroom design criteria and requirements are outlined in Articles 3.8.3.11 all the way to 3.8.3.17. So during your exam, if you're asked for any design criteria, it should be simple enough to just look it up within those articles. Now, a universal washroom needs to have a minimum 1500 millimeter turning circle and a 900 millimeter wide transfer space. You need a grab bar adjacent to the water closet as well as to the rear of the water closet. The water closet has to be accordingly so that a wheelchair user can do a lateral transfer onto the seat. A toilet paper dispenser in close proximity to the toilet, as well as a hand paper towel dispenser and soap dispenser in close proximity to your lavatory. In this case, as you can see, latch side clearance isn't met, so you would need a power door operator. And all of those requirements are listed in 3.8.3.12. Other items that are discussed in the accessibility section take into consideration counters, shelves or counters for telephones, as well as drinking fountains. The first one, counters, 38319, would be applicable to public service counters, etc. So the provision of knee spaces between desks or underneath desks, etc. All of that design criteria can be found under 38319. Last but not least, I'm going to talk about existing buildings and how the NBC applies to existing buildings. So the NBC applies to the design, construction, and occupancy of new buildings and the alteration, reconstruction, demolition, and removal, relocation, and occupancy of all existing buildings. First and foremost, the building code is not a retroactive document. So if I'm not doing alterations, I'm not doing renovations, I don't have to comply with the code. That's when you would have to comply with the fire code, because that is a retroactive document, because you have to assure the safety of your building is being maintained. However, the building code is not applicable because it's not retroactive. Once you change something in your building, you renovate something, you alter something, you expand it, you add to it, that is when you must implement and comply with the code. If you can't comply with the code, then you need to justify that it is not feasible for your renovation or alteration to comply with the literal application of the code, but you would still need to try and meet the code to the best extent possible. Now, you would have to justify that to the authority having jurisdiction, and they would have to approve it. But that's essentially how the NBC works in relation to existing buildings. And there you have it. I'd like to thank everyone so much for tuning in to watch this webinar on the National Building Code, understanding and applying the 2015 National Building Code, especially Part 3, Fire and Life Safety, hosted by yours truly, Samantha Crew, an Accessibility and Building Code Consultant. I would like to thank Afzana, again, the Director of RAIC Emerging Practitioners, for helping to organize this awesome educational opportunity. Should you have any questions, please feel free to contact me using my email or phone number allocated on this slide. As well, as a last tip for you guys studying for your exec exam, the best tip I have for you is understand your sections in the code. As well, keep your index nearby, so that way if you have a question that you're unsure, at least you can look quickly in the index for a keyword, and then next to that keyword you can find all the associated requirements. Other than that, I wish you the best of luck, and I hope that you learned bunches of information in this tutorial. Until next time, signing out. Bye.